Green, no, nga Strength of Materials nga book. So this is actually chapter 3 na no, sa to ang libro. And for today, we will be discussing torsion. So I know that you are familiar with torsion, no, or you have already idea since na cope up naman yun siya na topic, no, from physics. So ato lang siyang i-apply, no, sa engineering mechanics. So by definition, no, torsion is the twisting of an object caused by a moment acting about the object's longitudinal axis. So when we say longitudinal, so of course kani siya nga axis class, no, yeah, longitudinal axis. So we just have to remember the conditions, no, and the assumptions when dealing torsion here in mechanics of deformable bodies. First, we have this consideration or assumption that circular sections remain circular, no? So meaning when your object, no, with a circular cross-sectional area is subject to torsion, then its sections, no, remain circular. So dili siya ma-deform class. Okay? By the way, no, um, here in our mechanics of deformable bodies, so we are only considering circular cross-section areas. Anong circular mo lang ito ang gina-consider lang? Because class, when you have a square, no, cross-sectional area, imagine nga that is subject to torsion. So kaila man siguro mo shockwave, no? Shockwave kay nabitaw mo rag maglambod-lambod, di ba? So inana po ang itsura sa ato ang object, no? If square ang iyang cross-sectional area. So it will involve warping and it involves complex and complicated equations or solutions, no, in solving torsion for such cross-sectional areas. That is why the very common cross-sectional area, no, that involves torsion is kaning circular gina siya, no. So if you notice nga kanang transmissions, no, sa ang mga vehicles, ang iyahang shafts, no, is naka ano gina siya, no, circular, involved gina siya og circular. Or if ano gani, if involves rotation, no, circular yun ang ato ang cross-sectional areas nga ka-observe because so yun ra i-analyze si circular cross-sectional area class, no, tungod pud sa ihang property, no. Then second, we have here plane sections remain plane and do not warp, no. So again, mo ni siya kung gi-mention earlier, no, that if you have a cross-sectional area nga square, no, so mag-involve na siya warp, no, ma-deform ang iyahang dimension if ma-subject siya to torsion. So imagine na lang ng Rubik's Cube, no? If imo siyang i-rotate, diba? Lahi na yung itsura mo siya, mahimong diamond. Daghan siya og spike. So, lahi na yung itsura, diba? So, dili na consistent ang iyahang cross-sectional area all throughout the member if subject to torsion. Then, the third is we have the projection upon a transverse section of straight radial lines in the section remains straight. And shaft is loaded by twisting couples in planes that are perpendicular to the axis of the shaft. Now, di ba na-encounter naman nato ning couples, no, from statics of rigid bodies, no? So couples is defined by two oppositely directed forces but equal in magnitude. Okay? So dili lang siya limit sa forces, no? So it may also be moments, no? So equal in magnitude nga moments but oppositely directed, which is no na siya tong gina-consider here in torsion class, no, since it is the twisting of an object caused by a moment, no, acting about the object's longitudinal axis. Okay? Then lastly, stresses do not exceed the proportional limit. I know na kabalo na mo sa ato ang stress strain diagram, no, malocate na ninyo asa si proportional limit. And so you know the mechanical properties of each material na, diba? Or if any material, no? Or ang iyahang behavior sa iyahang mechanical properties. Sige. So, I'm about to present to you the equations, no, and formulas that involves or that will be used, no, in dealing torsion nga problems here in engineering mechanics class, no. So again, circular cross-sectional area lang ang ato i-consider, okay? Now, we have here angle of twist. No? So, later, that will be expounded. No, I will show you a video, a very detailed explanation, no? Crystal clear kayo ng explanation class, no? With simulation. So, I hope makita nyo na ang
Nakulit si sir.
Nawala ata si sir.
Nawala. Sir, asan ka na, sir?
Magana sa kay formula oy. Buwa.
Na all with simulation.
Sige ako nalit padayon guys. Sir lang.
Sige, go Jeff.
Yeah. So, ano alam ang presentation.
Go, Sir James.
Interested ng torsion ni Mujet.
Tulad.
Hello, everyone. Class,
Yes, sir.
napa ba po?
Sir.
Okay,
Napa,
okay. So, thank you.
Yes, sir.
Actually, nag-brown out og kalit sa ato ang school karon no, so wala may light and also ang internet connection so na-cut. So ang akong gigamit na lang karon is data, no. So I hope nga okay ra ang akong audio and ang ako ang slides nga i-present for a while. So ngit-ngit ko karon diri nga side. Sa Okay, so going back to the topic now, I hope okay ra ko audio ha and ako ang slides. Now, we have here angle of twist, no? So, later you will see if asa nga part sa to ang analysis na si angle of twist, not the equation or formula to be used to solve angle of twist is angle theta is equal to PL over JG. No? So it involves four components, no, in our equation. So let us define what are these. No? So angle of twist is measured in radians na siya class, no, since that is derived from arc length, no, of a circle. Then recall, di ba, from your trigonometry or geometry. So how do we compute for an arc length? Di ba? It is just equal to angle theta times the radius, where angle theta is in radians. That's why our angle of twist here involves radians class, no, or measured in radians. Then T, capital letter T, refers to your torque, no, applied or retortion applied to a member. Measured in Newton meter or in SI unit or in English system rather is pound inches, no? Then length is in meters or in inches, no? So depende siya sa ato ang system of units. Polar moment of inertia is measured as meters raised to fourth or inches raised to fourth, no? So in SI unit class, no, so Newton meter ang ato ang gigamit, di ba? But actually pwede ra pod na siya na Newton millimeters, no? So you just have to be consistent sa imong unit, no? So if millimeters imong gamit, so millimeters dapat ka sa length pati sa imong polar moment of inertia. Okay? since ang ato ang G or ato ang modulus of rigidity in Pascal, di ba? Pascal could be Newton per millimeter squared or mn per meter squared, no? So meaning, pwede na to ipares ang Newton and millimeter and Newton and meters. Okay, so you just have to be consistent, class kay. This involves four components, no? So naglahi-lahi og units. So dapat compatible ang imuhang units para walay discrepancy or walay error sa imuhang calculation. Okay? So, kani si modulus of rigidity class no kay kuan lang ni siya class. Isa lang ni siya ka property or mechanical property of a material. Igsuon ra ni siya ni modulus of elasticity. So, if sa modulus of elasticity, that is the property of your material, elasticity sa imong material no ang iyang gina-measure here pud sa imong modulus of rigidity ang stiffness pud ang iyang gina-check class no, so how stiff or how hard your material is no, so mo na iyang isa ka mechanical property sa atong material class. Then how do we compute for torsional shear stress? So we have here equations no for torsional shear stress. Tau, so represented by tau, di ba ato ang shear stress is equal to torsion rho over J. So, ang ato ang J dari class, mura na siya si polar moment of inertia. Okay? Then 0. Kinsa man ni 0, no? Then, to compute for the maximum shear stress, di ba? Notice the same as lag equation. But, for maximum shear stress, no, R ato ang gigamit or radius. Actually, class, kaning rho, it only refers to any given point, no, or at any given point sa imuhang radius bitaw sa imuhang material class. Di ba we are considering circular cross-sectional area? Meaning, if mo ni siya to ang radius, R, so at any point ana class, muna siya ang ato ang rho. Let's say for example, you are asked to determine the shear stress no at this point no of your object or of your material. So meaning, ang kana siya nga radius, di ba kanang small radius, muna na siya to ang ginatawag nga rho. Okay? So, rho therefore is just actually radius lang class, no? But dili katong maximum radius. So, to find the maximum shear stress, so your maximum shear stress class will actually occur at the outermost fiber no, of your material, which means that the maximum radius is where you can find your maximum shear stress. Okay? So, ana lang siya class. So, actually, kaning kuan class, no? Si solid shaft and kani si hollow shaft, dili na gina siya necessary nga memorization pa ninyo ng equation or formula for its maximum shear or maximum torsional shear stress nila class no, because that is just derived from this equation. Giderive lang na siya dari class. I-substitute lang ang J, no, ang polar moment of inertia. 'Di ba? We are considering only circular na cross-sectional area, meaning our polar moment of inertia for circle class is actually pi r raised to 4 over 2, no? So, maula na ato ang equation class. So, if naatay area of the circle equal to pi r squared, so ang ato ang polar moment of inertia for circles class is J is equal to pi r raised to 4 over 2. Okay? So, you have to memorize this one. Okay, ha? Take note of that. Oops. Sige. So, if ato na siyang i-substitute no, sa equation diri, sa maximum shear stress, J, no? So, cross multiply, you'll have 2t, so r up over pi r raised to 4, no? Then, kay r sa numerator, mag-cancel out. So, ang denominator no mabilin is pi r cube, no? Then, 2t ang denominator. So, dara lang na siya na-derive. So, if you are fan of memorizing equations, then you may do so, no? Pwede rin siya memorizon. Kaya para po nga, i-direct substitution na lang. So, if you have solid shaft, then, mura ni mong timan-an, no? Ana lang. But if you're not fond of memorizing a lot of, or plenty of formulas class, pwede ra yun nga kanira yun inyong memorize no, for maximum shear stress. You just have to understand na ang J, no, is your polar moment of inertia, no? So for circular shaft mo lang di ang ato, I mean for solid shaft, mao lang niya to ang polar moment of inertia since solid circle lang man ang iyahang cross section ana. And for hollow shaft, no? So recall from our topic na pressure vessels, no? So hollow vessels, di ba ito ang or hollow cylinders, ang ato ang gina-compute. Meaning nga na class, ano lang, ang ato lang polar moment of inertia for that no is pi over 2 times, ang radius na to dani is, so ano lang, capital or outer radius, no? Squared minus the inner radius squared. Kay hollow man siya, di ba? So, ano lang. Then, substitute that one here. Then, you will derive this equation actually. Okay? Sige. So, power. So, na-involve siya og power class no ang torsion because when your solid shaft class no is subjected to torsional moments class or torsion nga action class no, it actually generates power no. So, it torsion or actually or solid shafts no that is under torsion is actually used to transmit power. That's why ang kanang again, ang ako yung best example ana is ang kanang nagko kay tingog ano ato gawas. So that's why ang best example for this class is ang what do you call this? Kanang transmission bitaw sa ato ang vehicles, no? Mostly or not mostly but actually all of the shafts no na nag-involve sa ato ang vehicular classes circular na siya kay mas better man ang iyang cross section no and it can generate power no. So dira lang na nagikan ang iyahang ano class nag-apply lang siya sa ang ato ang concept sa torsion no sa ato ang vehicular nga mga machines class no or mechanism. So for power you have here an equation for power. P is equal to T or your torsion no times omega. So unsa man ni si omega? So omega actually is your angular speed no kay di ba nag-ingon ko nga when your circular shaft no, or solid shaft is subjected to torsion, then nag-generate na siya og power, no? So, i-multiply lang natin na siya by its angular speed, no? Kung how fast is your solid shaft rotating. Okay? So, mostly class, no, most problems or majority of the problems that involves torsional power class kay ginahatag ang rotation of frequency, no, or frequency of rotation. So, dili si omega ang ginahatag. But how do we compute for omega? So, recall that, di ba, in one revolution, you have 360 degrees, no? Or in radian, you have 2 pi r, or 2 pi radians, di ba? So, 2 pi ang imuhang isa ka revolution. Therefore, your angular speed is just equal to 2 pi times the rotational frequency, which is measured in revolution per seconds. Okay? So actually kaning power class naapod ni siya sa to ang topic nga naapod ni siya sa to ang subject course dynamics. It's just that sa course syllabus sa dynamics ang kani siya nga topic is nasa later part. That's why una nato siyang na-encounter diri sa mechanics of deformable bodies. But they are just actually the same. Okay? So anyway, and these are the fundamental equations or formulas no nga ato ang magamit in solving torsion nga problems here in mechanics of deformable bodies. Okay, so for sign convention, we will be using right hand rule. So later I will be showing to you kung unsa nato ato ang sign convention no, ang kaning right hand rule. Sige, so for now, I will present to you the fundamental concept no and principle of torsion no that is explained very clear gid kay ni siya class no with simulation gid siya 3D gid kaayo siya ba. So masabtan gid kaayo niya bantay o di pa gid masabtan after watching this explanation. So let me just share my screen. So I hope madungog na dayon ang audio.
Is the twisting of an object caused by a moment acting about the object's longitudinal axis. It is a type of deformation. A moment which tends to cause twisting is called torque. A common example of an object subjected to torsion is the
Pamati mo ayo class ha. Pay attention to the video.
transmission shaft, which is used to transmit power by rotation. This could be the drive shaft and axles, used to transmit power from the engine of a car to the wheels, for example. Or the shafts used to transmit power from the blades of a wind turbine to its generators. Let's explore what happens when we apply torque to a circular bar. We can see that the applied torque causes the bar to deform by twisting. An interesting thing we can observe is that individual cross-sections of the bar do not get distorted by the twisting. We can imagine that the bar is made up of multiple individual discs, which rotate relative to each other when the torque is applied, but do not deform. This is only true because the cross-section of the bar is axis symmetric. A bar with a rectangular cross-section is not axis symmetric, and so torsion results in warping of the bar cross-sections. This warping is complex, so in this video we will keep things simple and only consider torsion as it relates to circular bars. Let's fix our bar at one end, and track how a line between point A and point B deforms as we apply a torque to the other end. The applied torque causes the free end of the bar to rotate by an angle phi. This is called the angle of twist. It varies linearly from 0 at the fixed end of the bar to phi at the free end of the bar. We can calculate the angle of twist using this equation. It is a function of 4 parameters: the length of the bar L, the applied torque T, the shear modulus G, which is material property, and J, which is the polar moment of inertia. So, what is the polar moment of inertia? It defines the resistance of a cross-section to torsional deformation, due only to the shape of the cross-section. The polar moment of inertia for a hollow bar, with an outer radius RO and an inner radius RI, can be calculated using this equation. Setting the inner radius to 0 gives us the equation for a solid bar. One neat thing about the equation for the angle of twist is that it gives us a way to determine a material's shear modulus G experimentally. If we apply a known torque to a bar of known length and cross-section and measure the resulting angle of twist, we can use that information to calculate the material's shear modulus G. Torsion generates stresses and strains within the bar, which we need to be able to calculate so that we can make sure our bar won't fail. To figure out how to calculate these stresses and strains, we can start by observing how a small rectangular element on the surface of our bar deforms. The element is initially rectangular, but when the torque is applied, it gets distorted. Let's take a closer look. Because the bar is axis symmetric, we know that individual cross-sections will rotate but won't get distorted, so the sides CF and DE of the element will only move vertically along the lines shown here. After the torque is applied, the angles of the element are no longer 90-degree angles. This gives rise to a shear strain, which corresponds to the angle you can see here. We can calculate the shear strain by considering only the geometry of the bar in the deformation. It corresponds to this angle between AB and AB prime. We can use trigonometry to derive an equation for shear strain. For small angles, gamma will be approximately equal to the tangent of gamma, which makes it equal to the length BB prime, divided by the length AB. AB is the length L of the bar. We can calculate the length BB prime by realizing that it is the arc length of a circle with a radius r, covering an angle equal to the angle of twist, theta. So the shear strain is equal to the radius of the bar multiplied by the angle of twist divided by the length of the... But what about inside it? It turns out that the shear strains increase linearly with the distance from the center of the cross-section. So if we define ρ as the radial distance from the center of the cross-section, we can replace r in this equation with ρ. to give us an equation we can use to calculate shear strain due to torsion at any point within the bar. That's shear strains covered. But what about shear stresses? Like the shear strains, shear stresses increase linearly with the distance from the center of the cross-section, with the maximum shear stress occurring on the outer surface, as you can see here. This is true for a solid bar, but also for a hollow bar. This is useful to know because it means that hollow bars are way more efficient at carrying torsional loads, since the central part of a solid bar is only resisting a small part of the total load. Let's consider a small element within our cross-section that has an area equal to dA and is located at a distance ρ from the center of the cross-section. The internal force acting on this element is equal to its area, dA, multiplied by the shear stress τ. We can use this information to work out an equation for calculating the shear stresses. The moments caused by the internal forces acting on all of the elements within the cross-section must sum up to be equal to the torque T. Otherwise, equilibrium is not maintained. We can represent that mathematically by this integral. We know that the quantity τ divided by ρ is a constant, because the shear stress varies linearly with the distance from the center of the cross-section. So we can rearrange the terms and move τ over ρ out of the integral. It turns out that the integral we now have on the right is actually the definition of the polar moment of inertia, so we can replace it with the letter J, and we can rearrange this to get an equation for shear stress. The shear stress is a function of the torque T, the distance ρ from the center of the cross-section, and the polar moment of inertia J. It's quite a simple equation. So we now have equations that allow us to calculate the shear strains and shear stresses. We also have the equation for angle of twist that we talked about earlier. These three equations tell us everything we need to know about a circular bar which is under torsion.
Okay. So, sabtan? So, karo kayo ang pagpa-discuss ngayon, no? With simulation pa yun sa solid shaft, no? So, that way, mas easier siya sa buton kay makita na to ang iyahang figure, di ba? Sige, so let's just continue our discussion. So, to further illustrate and better understand the concept and principles of torsion, let us solve problem solving or sample problems rather. Okay, so we have here situation number 1. A shaft with constant diameter of 2 inches is loaded by torques applied to gears fastened to it as shown. So if the modulus of rigidity of the shaft is equal to 12 times 10 to the power of 6 psi, compute in degrees, no? Compute no in degrees na ko no class. The relative angle of twist between gears A to D, no? So from this point up to this point, dara daw, iya daw relative angle of twist. Okay, so how do we solve for this? So actually class, to solve for the relative degree or for the relative angle of twist between gears A to D, we'll just have to sum up the angle of twist, no, per segment. So ato lang siyang i-sum up, no? So meaning, angle of twist from A to B plus your angle of twist from B to C and your angle of twist na from C to D, di ba? So from A to B, B to C, and C to D, no? Ana-ala na to siya pag-analyze. Then eventually, we will obtain the relative angle of twist, no, between A and D. Okay? Now, how do we find the angle of twist, no, for member or for segment AB, segment BC, and segment CD? So, recall na from our equations, di ba, we have an equation for the angle of twist, which is, it is equal to TL over GG. See. So, angle of twist is just equal to TL over JG. Okay? And since ang solid shaft na to is constant, no, from point A to B, constant ang iyahang area or iyahang cross-sectional area as well as ang iyahang modulus of rigidity. So, constant lang ni siya diri class. Ang difference lang class no, or mag-differ lang ang ato ang angle of twist no from each segments sa iyahang torsional stress or sa iyahang internal torsional stress and ang iyahang original length. Okay? So first, let us draw the torque or the torsional diagram. Let me just add another slide. Sige. So if we have this solid shaft, no? So butang nato muna si point D, si point C, si point B, and si point A. Ato i-determine ang iyahang torsional diagram. So how do we determine that? So this is just similar to force diagram class. Hiwi kayo for all. Okay, anyway, now, di ba I have mentioned that our sign convention no, for torsion, we will be using the right hand rule. So when we say right hand rule class, wait ha, ako lang i-apply ang torsions no or the torsions on each points. So from for point D, you have 600 pound-feet daw nga torsion no, that is acting in this manner. So 600 pound force. Sige, si point C. So ani ang iyahang direction. Okay, so opposite siya ni point D, di ba? And 1,000 pound force ay pound feet no ang iyahang magnitude. So for point D, you have the same direction with point D. So meaning, inani iyahang torsion class and 900 pound-feet ang iyahang magnitude. For point A, so same direction diba with point C. So inani lang yapon ang iyahang direction sa imong torsion no, at point A. And it is equal to 500 pound-feet. Sige. So if we're going to analyze no from point D no gikan pa kang point D, mamili mo class no either dari ba nga face or dito no sa face ni point A ato i-analyze no for this illustration diri lang ta kung point D kay nakaatubang naman siya diri daan mas dali siya tan-awon no. So if ato na siya i-analyze no nga face sa to ang or nga plane no sa to ang member, so and atong i-apply ato ang right hand rule. So when we say right hand rule class, ani man gud ang mahitabo class? Okay, so sige ha, si point D ato ang unahon. Point D, di ba, inani ang iyahang rotation. Sorry, baliktad. Ani, di ba, yung rotation? And if atong ibutang no, itapad ang ato ang right hand, kang point D, so makakulob na siya, di ba? Inani ang itsura, class. No? Inana, di ba, ang itsura? So meaning, nisabay ang direction sa imong torsion, no? Sa curl sa imong kamot, sa imong fingers, no? So, when you have that condition, class, consider positive sign convention. And for point C, since opposite man yan, no? So, of course, that will have a negative sign convention, but the rationale is actually when you have an opposite direction, no, sa imong right hand rule. So, if ibutang na tato ang right hand, kang point C, no, at this face, so, same gihapon na og figure. Or, no, inana gihapon, di ba? So, meaning class, in this case, ang imuhang curl, no, sa imuhang finger, wala siya ni sabay sa imuhang direction sa imong torsion, no? So opposite ang ilahang direction, di ba? Meaning, in that case, you will be adapting a negative sign convention. Okay? Nasabtan ba si right hand rule? So ang ang tan-awon lang nato class is kani bitong curl sa to ang kuan finger kani siya. Kana siya class ba? Ana imuhang pag-analyze ana class. So meaning class, if ibutang nimo siya kang point D and musabay ang direction bitaw ni point D, so if ang rotation no or ang direction sa imong torque or sa imong moment point D is acting this way, so meaning nisabay di ba siya sa curl sa to ang finger kani siya ana. So meaning positive sign convention. Then kang point C, so ang point C is ana iyahang direction di ba? Going this way, paani. Opposite siya sa curl sa to ang kamot or sa to ang finger sa right hand. So, we will be adapting a negative sign convention of moment or torque. Okay? Mamweng, wala. Ang aircon, wala pa. Off pa. Mura igang na. Thank you. Okay. So, going back to the topic. So, I think that sign convention, meaning class is 600 pound feet na torsion will be unsa man, di ba, positive, no? Kay mo sabay if ibutang nato siya sa dari nga face, no? So, when you analyze class, no, you have to be consistent, no? So, if dari ka mag-analyze kang point D, so dapat kang point C, dari po ka nga face mag-analyze, kang point B, dari po ka nga face mag-analyze, and also, kang point A, dari po. Okay? So, if baliktad po, no, dari po sa luyo, dari nga part ka mag-analyze, so, dara po ka nga part mag-analyze. So, meaning, if ato ibutan atong right hand ana class, it will have this convention, no? Inani ang itsura class, oh. For example, kung dari nga part ka, ato lang siya i-ana, for example ha, itong tanaw na to siya top view, ang imong kamot or imong right hand, inani ang itsura. And if kanipon nga face ang atong i-consider, dari siya nga part, so ang imong right hand ana is pabaliktad, no? Dapat outward ang iyahang kuan ka sa direction sa imong thumb. So your right hand will look like this. Forgive me for my illustration sa kamot. So ana, di ba? Imagine ba ninyo? So kung right hand, di ba? Ana iyahang direction. Okay? Inana nga tong direction, ana nga to ang moment kang point D is somewhat inani ang manner. So, if kani po lang ito i-consider, so your 600, no, will be negative, di ba? Kaya opposite man siya sa direction sa to ang curl sa to ang right hand, di ba? Okay? Sige. So, at 600 or at point, you have a positive sign convention of torsion. So, musaka taan na by 600. So, 600. So, kani siya kay bali ang ato ang solid shaft, no? Sa atong reference point or ang ato ang baseline, no? So, si 0. And then, since we have a positive torsion, so musaka lang siya by 600. And since wala may torsion or wala moment na evolve, no, between point B to C, so constant lang na siya, no? Straight line lang. So meaning at point C, 600 ya po ng imong elevation, no, at that at this point. And then at point C is subjected to torsion nga negative sign convention, no? Kani siya class, oh. So meaning 600 minus 1,000. So 600 minus 1,000, di ba, that is negative 400. Kay mas dako man og value ang ato ang negative. Yeah, it's negative 400, no? Mas dako man og value ang ato ang negative sign. So meaning from C to D also wala siya moment or walay pa nga nag-act. So, constant lang po na siya. And at point B, it is subjected to a positive sign convention of torsion nga 900 ang magnitude, no? So, negative 400 plus 900. So, mag-positive na siya, no? Kaya mas dako man ang value sa 900, which is positive ang sign. But, minus 400, so 500 lang, no? The ring apart, 500. Pasabot laan ng 900 plus, no? From this point to this point, dapat 900 na siya, di ba? So, 500 plus 400, you have 900. And then, again, walay moment no, or walay torsion na involved sa imuhang segment A to B, no? So, constant lang na siya. And then, at point A, okay, you have a negative sign convention, di ba? Of moment or of torsion na ang magnitude is 500. And this is 500. So, meaning, mag-zero lang ang ato ang TD or torsional diagram. So, you have to understand this class ha kay. This is very important nga diagram class kay magamit po nato ni siya sa to ang next topic, no? After midterm na to nga discussion. So, chapter 4 kay bala siya sa to ang book. So, kani gid ato ang mahimong basis sa to ang solution. Okay? So, nasabtan na ba gyud unsa ni pag-create? This is called force diagram class no, or rather torsional diagram kay torsional man ang, torsion man ang involved diri, no? So this is just similar to force diagram, no, from our previous topics, di ba nga, we are solving common bars. Actually, pwede na to siya i-graph ang ihang force diagram to express or to determine, no, the internal forces of your bars. Okay? So, meaning class, no, at member or segment rather, no, segment C to D, your internal torsion, no, is 600 pound-feet. Okay? And at segment B to C, your member, no, is subjected to negative 400 pound-feet nga torsional force, ay yung torsional nga action. And also, for member A to B, no, so naa siya 500 pound-feet torsion, no, or internal torsion. Sige. And how do we determine gali, di ba? The angle of twist, di ba? It's just the internal torsion, no, of your member, L over JG. Sige. So, actually, pwede rin na siya isumpay class, no? So, internal torsion of member A to B or segment A to B times length of your A to B divided by JG of the material plus the internal torsional resistance of your B to C nga segment times the length of your B to C divided by JG plus so on and so forth, no? Or for members, di na po. But taas kayo siya kung ako siyang usahon. So, better nga ako na lang siyang tinagsaon og solve. So, unahon na to si A to B. Sige. A to B is the torsional equation niya is the torsional of your segment A to B times the length of segment A to B all over JG. So, din na ko siya indicate as A to B and G A to B since constant lang man all throughout the segment or from A to D. The same lang man ang ato ang polar moment of inertia and modulus of rigidity. Okay? So, substituting the datas given, we have okay, so si TAB class, no, si internal torsion of segment A to B, mo ni siya class, internal torsion niya, which is 500 pound-feet. And remember that in order for our units to be compatible, no, or to be consistent, di ba ang ato ang torsions kay naka-pound-feet? So, ato na siya i-convert no, into pound-inch. Okay? So, from 500 pound-feet, So kung ato na siya i-convert into pound inch, so of course, 1 foot is just equal to 12 inches, di ba? Cancel, cancel, meaning ang iyahalang conversion factor is, i-multiply lang nato siya by 12. Then the resulting unit will be pound inch. Okay? So in this case, ato lang na siya i-multiply by 12 para ang ihang unit is pound inch, no? Then length, you have here for A to B, 5 feet siya, no? So ako lang yung pala i-convert into inches. So 5 times 12. So kani siya, naka-inches na ni siya class, no? Ihang unit. And then ato ang J or the polar moment of inertia, no, for your shaft. Diba atong equation is pi radius r, no, raised 4 over 2. So, what is the radius of our material or our shaft? 2 inches ay iyahang diameter. So, meaning iyahang radius is 1 inch, no? 1. Then, multiply by G, modulus of rigidity, which is given, no? 12 times 10 to the power of 6. PSI or pound per inch squared. So, compatible, di ba? Inches. This is also in pound, in inches, no? Naki-convert na siya, and also pound inches. Okay. Sige, so how much is our angle of twist, no, from A to B? Pila man ay class? Kindly calculate. One point. Unsa may tinuod ani? 0.019 or 1.094?
Wala to yung labot ang 57.3, sir.
What do you mean 57.3?
Kay sa book, manggod kina siya kuan.
Okay. No, so nag-follow day ka sa book. So sige, sir, Gar lang na ang solution sa book. So kanila sang i-compute.
Okay, sir.
Okay.
0.019.
So anyway, 0.019. Sige. No? So meaning, we have 0.019 ng angle of twist for segment A to B. So take note that 500 times 12, meaning this is in pound inch, and this is in inches, and then kaya ito na siya i-separate para dili siya libog. So the units class no sa may unit di ba? The torsion is pound inch ang given, and then ang length no is in inches siya all over. Kani si moment of inertia or the polar moment of inertia is inches raised to 4. Then PSI or pound per inch squared. Okay? So, meaning class, sa numerator, you have pound inch squared, which is mag-cancel out lang ni siya class, di ba? Cancel. So, remaining here is inch raised to 2. Mag-cancel po yun na siya. Mag-cancel po na siya. So, walay mabilin nga unit class, no? So, unit class ni siya. But actually, your angle here is in radian, no? Always remember that. Naka-radian pa na siya. And you are asked to determine the compute, no, the relative angle of twist in degrees. No? So, sige lang. Later, we will convert. So, na siya na ang nasa libro is, iyan na siya i-diretso or i-direct niya o substitute or convert no ang angle of twist into degrees. So pag i-multiply mo siya by 57 point katong something, then you'll obtain naka-degrees na siya ng angle of twist. Either way no or either path of solution is just correct. So ang atong objective lang is to obtain the relative angle of twist na between A and B. Okay? So, later na lang natin na siya i-convert para mausal lang. So, if you are wondering, asa na agikan si 57 point something, so it's just from 180 degrees over pi. Okay? So, if i-divide mo na siya, you'll obtain 57 point something. Sige, next. Si angle of twist for asa na ta? A to B, so B to C. B to C. So, of course, your internal, or yeah, the internal torque of member, segment B to C, which is pila to? So, nara. So, di ba, muna si B to C class. B to C, A to B, and C to D. Now, for B to C, you have negative 400, no? Sige, so you have negative 400. So, naka-pound feet pa na ang yahang unit, di ba? So, ato lang po siyang i-multiply by 12 para ma-convert siya into inch, no? So, pound inches na ang ato ang unit times the length, no, of your segment B to C, which is 3 feet, no? So, again, ato lang siya i-convert into inches. So, 3 times 12, then naka-inches na na over the polar moment of inertia for B to C, which is constant lang. The same lang ani ato ang denominator, no? For member A to B. So, you have here 1, since 2 inches yung diameter, no? Over 2 times modulus of rigidity, 12 times 10 to the power of 6. So, this would be, or this will yield a negative answer, no? Kay negative 400 man ang ato ang torsion. And how much is this? Negative 0.009. Radian, no? Ang ato ang angle of twist for B to C. Sige, so for segment C to D, no? The internal torsional moment, or the internal torsion, no, at CD, you have positive 600, di ba? Kanisya class. So, 600, again, naka-fit feet, pound feet na siya rather, no? So, ato lang siya i-convert by 12 para mag-pound inches na siya, no? Then, times the length of your number P to D. So, 4 feet, di ba siya? So, 4 feet, so i-multiply na to by 12. So, may mga na siyang inches, no? So, JG would be the same lang ani, no? Kay constant laman ang ato ang cross-section. Sorry, this is not squared for the class. So, kindly recalculate. So, this is raised to 4. 4 ang ato ang, pi r raised to 4 ang polar moment of inertia. Times 12 times 10 to the power of 6. So, pila lagi na siya, class? Pila si B to C and si C to D. Asa man ni si 0.018 kang B to C?
Same ra ang kwan ganyater B to C. 0.09 yater.
Kani siya?
Yes, sir.
Yeah. Anyway, regardless no kung pila pa naka-square is just 1. 0.009 to then 0.018 radian. Okay. Now, di ba, to determine now the relative angle of twist of your gears A to D. So, ano lang class, di ba, summation lang of angle of twist na of each segments or sections. Therefore, ato lang siyang i-sum up, no? So, for A to B, you have 0.019 minus for B to C, so negative man siya, so minus 0.009 plus C to D is 0.018. So how much is this? 18 point, 18? Ano daw, tulig 18 nga. 0.0 man is something sila. 0.028. Okay. You have 0.028. So this is in radians, di ba? So this is actually the angle of twist, no, of your ear from A to D, but in radian. But since we are asked to compute for the angle of twist in terms of degrees, so ato lang siyang i-convert no into degrees. So how do we convert? So di ba, ato na siya i-multiply 180 degrees over pi rad. So cancel, cancel. So 0.028 times 180 degrees over pi. How much is this? Correct answer. So how much is 0.02? Okay, natay 1.604. 1.604 degrees, no? So this is now in degrees. And this is now our final answer for situation number 1, no? So it is same sa book. So, bawal man siguro, no? Sige. Wala question? Nasabdan ha? Anak lang siya class, di ba? So, ano lang siya. Medyo direct substitution, then you just have to be consistent lang yun sa imuhang units. Bantayan lang yun ang imuhang unit, no? They have to be compatible with each other. Sige, let us solve the second sample problem for this session. And this is actually the last sample problem, no, for this meeting. We have here two solid shafts of different materials are fastened together and attached to rigid supports as shown. The aluminum segment is 3 inches in diameter and has a modulus of rigidity equal to 4 times 10 to the power of 6 psi. The steel segment naman has a diameter of 2 inches and a modulus of rigidity equal to 12 times 10 to the power of 6 psi. Now, the torque, no, on or acting at the junction of the two segments is equal to 10 inches. Now, we are asked to determine the maximum shearing stress developed in the assembly. Okay? Sige, so shearing stress, no? Ato ang ipangita. So, si tau. No? T-max or tau max. Sige. But first, we'll have to determine the internal portions, no, of your materials, each materials, no, for aluminum and steel. Sige. So you have a moment, no, at supports. No, that is a fixed support man, no. So you cannot say that your moment or summation moment, no, at point at supports of aluminum and steel is equal to 0. Okay, they have, or so fixed supports have resistance to moment. Okay, sige. So how many unknown reactions do we have? Diba we have 2, 1, and 2. So we have 2 unknown reactions or resistive forces. In this case, moments. Okay, and pila man ka available independent equations of equilibrium ang atong magamit in this case. So in this case, very evident no, we cannot sum up forces kay wala may force nga involved dira, no. So the actions or course of actions or loads nga applied sa atong member is actually in moments, no, naka-moment or torsional ang iyahang loads, meaning hindi na ito magamit ang ato ang summation of forces, x and y axis. So the only independent equation of equilibrium that we can use in this problem is the summation of moment, no? Which is, or which should be equal to 0. Anong i-equate man nato siya to 0? Because this is to obtain or to achieve static equilibrium na state sa ato ang material class, okay? Because if you have a resulting moment, no, meaning an class really stable ang mga structure, so unsa lugar na tuyok-tuyok na siya, no, na lugar movement no gagakahitabo. So to maintain and to obtain static equilibrium of our material, so your resultant no a moment should be equal to zero. Okay, so summation of moment equal to zero. So by right hand rule, ato lang i assume no ang ato ang reactions or ato ang reactive moments at supports for aluminum as in this manner no or opposite the torque acting on the junction no. So pati si support nato kang ato lang siyang ipa-resist kibali ba no. So ang concept class is the same na siya sa kanabitang ani class oh. When you have simple beam, di ba? So mura na tag nagkuha og reaction actually. So for example, it's just that naani siya ay in terms of moments no ang ato ang gina resolve. So when you have a force P, so how do you compute or unsa gali ang ato ang automatic nga murag assumption ng reaction at supports, di ba upward man? O unsa man ilahang nature no or relationship between your P. So it's just that opposite siya sa direction sa imong load applied, di ba? And so of course when you have support, so ang purpose is to resist those load no or those loading. So opposite in direction lang. So in which mo po nato ang gi-adapt nga concept here no. So kamo actually ang mag assume sa direction sa inyong moment no or moment at supports. Okay? So it's just that in this problem gihatag siya diretso. But if wala gani class no, so assume the direction of your moments no at supports. Sige, which is just opposite your what do you call this? Your torque applied no at junction. Okay? Sige. So applying the right hand rule class. If tan-aw na to no, sige diri nga face ang ako ang i-analyze sa left side. So if ato na siyang tan-awan nga part okay. If atong ibutang ato ang right hand dara, so nakakulob siya no outward ang thumb. Okay? So it will have this convention, di ba? Meaning class, ang ato ang moment no at support at aluminum nga support no is sabay siya, di ba? Ang iyang direction is going with the flow or sabay siya sa to ang curl sa to ang finger, which means that your moment no at support of your aluminum or your torsion no at aluminum or support of aluminum, positive sign convention na siya no. Then balhin ta diri at point C. So obviously opposite no, since ang ato ang direction sa atong kamot is somewhat paana man di ba, and ang direction sa imong moment no is opposite, mura ihang gitabo. Okay, so meaning we'll be having a negative sign convention of for T, and lastly for what do you call this, for support no at steel. So sabay gihapon, di ba? Or rather, diri na siya nga face dapat left side, di ba? So ang direction no, so padigto gihapon siya atong kamot or atong finger. So positive sign convention. Or pwede sa class nga isa lang ang inuhimuon bitaw nga basis. So if you have a positive sign convention nga inani ang direction no, so opposite ana, so automatically mag negative na ano din ang kapes pud niya nga direction positive na pud, which is in this case parehas ba si support no at aluminum and steel. Sige. So with that sign convention no, so summation moment equal to 0, so it's just the aluminum or your torque no at aluminum plus T at steel or supports no or your torque at support nga steel minus the t, which is equal to 10 kips, di ba? So, 10 kips equal na to 0 since wala na may lain torsion or moment nga involved. Now, ako lang siya i-simplify, no? So, torsion at minimum plus your torsion no at steel equal to 10. So, take note that this is in kips, di ba? Kips inches. So, ato na siyang i-convert na lang diretso into pound inches. No? So, to do that, di ba, 1 kip is equal to 1,000 pound inches. So, ato lang siyang i-multiply by 10, no? To the power of 3. So, this is now in pound inches. Okay? So, for a while lang class, ha? Mag-CR lang ko for a minute. So, I'll be back.
Saan na to patungo? Hindi ko na kasi alam. Hinahanap ang sagot sa bakit. Hindi ko na kasi alam.
Okay, so going back to the discussion, no? Asa naman ta? So, natin isa ka equation, no? So, we have this, ako lang i-delete ang unit, ha? Equation na dayon, no? So, this is now our equation number 1. Okay, now, this is actually a kuan class, no? A problem on statically indeterminate nga structure. Ano man? Because you have two unknown variable, di ba? Or two unknown reactions. Then, ang atong available lang na independent equation of equilibrium is isa lang, which is kaning si moment, meaning mas daghan na nga to ang unknown variable or resistive forces or moments, mas daghan siya sa to ang available independent equation of of equilibrium, which means this makes our structure statically indeterminate. So, in solving torsional problem no, with statically indeterminate structures, ang concept na to sa statically indeterminate structure class na sa atong topic na simple strain, same lang yapon siya o concept class, which means that unsaon kaya nato pag generate og another equation or unsaon kaya nato pag obtain og equations of compatibility, di ba ato laman i-relate ang iyahang deformation. So in this case class, no, your deformation is actually in the form of angle of twist. Ano man. Because as explained earlier, di ba, in the video, if we consider na to ang deformation sa to ang deform or subject to rotation, no, nga member or nga torsional nga solid shaft, di ba, nag-refer lang man siya sa iyahang angle of twist. So, if tan-aw na to ni siya class, no, ipikat na to siya dari nga part, no, dari nga section, and tan-aw na to siya perpendicularly. So, di ba, inani iyahang cross section, no? So, for aluminum, kaning big circle, no, then small circle is for the steel. So, di ba, for steel. And if you consider na to, no, ang iyahang centroid, no, or iyahang center of gravity, iyang section. So, if mo rotate siya, no, so from this position, butang to si point A, then mo rotate siya, subject siya to torsion. So, naa na diri si point A, di ba? Pato siya ibutang A prime. So, meaning class, no, your angle of twist diri class, no, they are just equal, di ba? Equal naman yung angle, but they have different value for arc length. Kay gamay man ang radius, no, sa ato ang steel, and sa atong aluminum is mas dako ang iyahang radius. So, meaning class, no, with that being said, we can say that our, ako lang siyang parang ako space, no, our angle of twist, no, for aluminum is equal lang, no, to the angle of twist of our steel. Okay? So, meaning class, we now have this relationship, no, of their deformation, or in this case, no, in lahang angle of twist. Sige. So, as continuation, no, let me just add another blank slide. So, now, let's just analyze them separately. Ha? Lang siyang analyze on si angle of twist of aluminum alone. So, the angle of your aluminum, no, or the angle of twist, no, of your member aluminum is, diba, is just ito equation sa to ang angle of twist is TL over JG, no? So, the internal torsion of your aluminum times the original length, no, of your aluminum over the polar moment of inertia of your aluminum and the modulus of rigidity of your aluminum. So, substituting the necessary data to our equation, unknown, di ba, ang ato internal torsion in our material aluminum times length, no, of the aluminum. Length of your aluminum is, okay, narasi aluminum, no, na-crash out. So, 6 feet daw. So, again, ato lang na siya i-convert into inches. So, multiply tag 12 inches, no? Over the polar moment of inertia of your aluminum. So, polar moment of inertia of a solid shaft is just pi radius, which is radius for aluminum is 3 inches ang diameter, meaning 1.5 ang radius. So, 1.5 raised to the 4 all over 2. Then, modulus of rigidity for aluminum, we have 4 times 10 to the power of 6 psi. Okay? So, how much is our angle of twist no, or member aluminum. So in terms of the internal torsion no of aluminum PA. So pila man ni class? Pila man ang 6 times 12 all over pi times 1.5 raised to 4 over 2 times 4 times 10 to the power of 6. You have here 2.263 times 10 to the power of negative 6. So, asa mura
264 na.
duha ang nag-answer sa 2.264.
264 na siya.
So, 2.264 times 10 to the power of negative 6 TA or the internal torsion of aluminum. No? So, ina na ihang expression sa to ang angle of twist. Now, for the angle of twist of your steel, so equation is TL over JG, no? So, substitute ko siya directly. So, the internal torsion of your steel times length of steel is 3 feet. So, 3 times 12 all over J, polar moment of inertia of steel, no? So, radius or diameter of your steel is equal to 2 inches daw, no? Nara klase steel. So, 2 inches in diameter, meaning radius is just 1, no? Raised to 4 over 2 times the modulus of rigidity of your steel na 12 times 10 to the power of 6 psi, no? So, how much is the angle of twist or your member nga si steel, no? So in terms of TST, no, or internal torsion of steel. One point nine 10 or 91, sige, 1.910 times 10 to the power of negative 6 PST, no? Now, di ba we have an expression na for our angle of twist, no? For both materials, sa aluminum and si steel. And we also have this relationship no, of their angle of twist. So, ato lang i-equate no, ang both equations for expressions. So, the angle of twist for your aluminum is equal to your angle of twist in steel. Therefore, 2.264 times 10 to the power of negative 6 TAL is equal to 1.91 times 10 to the power of negative 6 PST, no? So, di siya maiigo. So, sumpay na siya, class, ha? Times 10 to the power of negative 6. Okay? Sige. So, let us express the internal torque of aluminum no, in terms of TS, meaning divide both sides by 2.264 times 10 to the power of negative. So, you'll have how much, class? So, therefore, this is the internal torque of aluminum. 0.844. See, you have 0.844 internal torque of steel, no? So, muna ilahang relationship class no of your internal torsion no between both materials. Sige. Now, notice that na-express na to ang internal torsion of aluminum in terms of the internal torsion of steel. And if you will consider equation number 1, no, from this, so if i-substitute na to ang expression of for ang internal torsion of aluminum, no, as a function of the internal torsion of steel. So in that resulting equation, isa na lang din ang antong unknown variable, no, which is the internal torsion of steel. Meaning, masolve din na to atong equation class, no. So makuha na to una si TST. So substituting the the expression of your aluminum to equation number 1. So you have diba that was TAL plus TST. So TAL is equal to 0.84 for TST plus TST is equal to 10,000 or 10,000 times 10 times 10 to the power of 3. Sige, so how much is your internal torsion class for steel? $5,422.993. 5,422.993. So this is in sa maya to ang resulting unit for this, no? So this is diba in PI or pound inch, and so this is torsion, diba? So meaning pound inch also. Hindi ako siya i-box kaya di man siya to ang final answer, no? Since ang ato ang ipangita diri is maximum shear. So shear stress, no? So dili na siya shear stress, no? These are just your internal torsional stress or torsional action, no? Nga load sa imong member or sa imong structure. Now, nanatay internal stress or internal torsion for steel. And we have this relationship, no, sa imong internal torsion for aluminum. So meaning class, TAL the class na is just equal to 0.844 TST. Or if ato na siyang i-substitute directly, no, your TST is just equal to 5,422.993. Therefore, how much is your torque, no, at aluminum nga support? So these are torsions na class, no, at support, no, or na at fixed support, no. These are not internal drive. So pila man class? $4,577.006. Okay. Now, we are not yet done because again, shear stress ato ang ginapangit torsional shear stress and maximum, no. So sige, so for steel, ako na siya i-label as T mass of steel is equal to sa ito equation, diba, it is TR over G, no? Mamo na ito ang equation for maximum shear stress or maximum torsional stress. Okay. Yan na siya class, Sige, or you can actually directly use this one, no? Kay solid shaft naman ni siya. So, pwede na po ni siya. But, for me, mas convenient ko nga kanigid ako ang gagamit. Okay. naanad ko. So kamo pwede ra pud nga katong derive equation, no? Sige. So this is R, ha. So for steel, no, you have TST, so 54 taon, 5,000 rather, no, 5,422.993 times radius sa imong steel. Ito, 2 inches ang diameter, meaning 1, no, ang iyang radius, so 1 lang na siya. All over the modulus of rigidity, the polar moment of inertia no, of your steel nga section, which is circular, so pi r 1 inch lang ang iyang radius no over 2. So how much is the maximum torsional shear stress for steel? Pila man na, class? Ha? 3,452? Sige. So you have 3,452 point 385. Okay, so unit, so since we are computing for shear stress, no, so PSI ni siya. Since this is in inches raised to 4, then our torsion is in pound inch. Is inch ka pa ni siya, no? So inch squared ang naa sa numerator. Then mag-cancel. So the resulting unit would be pound per inch squared or PSI. Okay? So this is now our final answer na for maximum shear stress at steel. How about for aluminum? It's just aluminum, or the torsion, no, of your member aluminum is 4,577.006 times, okay, for a while. Ako siya i-rewrite here. Oops. Oops. Sige, try na ako siya isulat. So for aluminum class, no, your maximum shear torsional stress is TAL 1,577.006 times length of your steel, or rather aluminum, no, 6 feet. Sige, let us convert it into inches times 12 all over pi radius of your aluminum is 1.5 inches, no, since 3 inches man yung diameter. Raised to 4 over 2 times the modulus of rigidity. 4 times 10 to the power of 6. Now, how much is our maximum torsional stress, no, of aluminum? Ilan man ni class? Okay, sorry for a while. Sorry, no, katulog nga ko. Kung sa'yo pa ang equation. We are competing for
Okay, answer,
maximum
sir.
shear stress. So kanina ay
Oo, wala pa rin.
yeah. Dami class ay katulog na ako class. Okay, TR na natong equation ni ba for maximum shear stress dapat torsional sa imong member is radius. So T AL na to is kani siya, diba? Then radius of our aluminum is 1.5 kay 3 inches man siya, diba? Sige. 1.5 over J, no? J nga polar moment of inertia which is 1.5 ang radius raised to 4 over 2. Now, so di na siya raised to 4 na siya class. So, how much is the maximum torsional stress, no, or the maximum torsional shearing stress at aluminum? 863.352. Sige. 0.352. So, PSI. Nagyan ko, no? Kay this is in pound inch, tapos is in inches. So, sa numerator, pound inches squared ang resulting unit, and sa denominator, you have inches raised to 4, no? Cancel out. Pound per inch squared ang result, which is just PSI. Okay? Nasabtan? Questions so far? Clarifications?
Na, sir.
Okay. Sige ha, I hope na nasabtan na ang lecture on torsion for both. Okay, na question si Mr. Blay, Joey.
Excuse me, sir. Sir,
Knowledge.
kanin sa kwan, sir ba? Equation 1 bitaw, sir. Pwede rag i-insert na dito ang sa kwan, sir, katong sa steel na,
Here.
sir. Para pagkuha sa kwan, sir, sa abad to? Sa aluminum.
What do you mean i-insert ang
Katong, di ba, sir, ang
equation for
unang
steel? Asa man mo na po ang
kwan, sir, kay
Mhm.
naman di
Kani
difference,
siya?
sir, sa kwan, sir, yung answer, sir, kay murag sa decimal ra nun, sir. 0.67
it
yang
doesn't matter
difference.
kay sa final answer pila man.
Wala pa po na ako gi-try sa final answer, sir.
Wait na. For a while, akong tanawon sa book. Kay, alam po na kung nagita naman sa book. Ang sa day, pamagi sa book, be. Yeah, it's illustrative problem. 864 and 3450. Yeah, because ang sa book magul class kay iyang gipang round up. Notice that in sa niyang aluminum, torsional aluminum is game on of 4580, no? Then ang iyang steel is 5420. Iha gyud bitong gi round up and gi round down, no? Kay ang iyang good purpose na class kay para mag zero, totally zero gyud ang iyang torsional diagram. Kay when you add these two, kaning naa sa book bitaw, kani si $45.80 and 5420. That is equal to 10,000. Tama ba? And remember that our equation 1, no, or the summation of moment, no, in this member or structure should be equal to 0. That's why napatungaan, no, sa imuhang aluminum nga support and sa imuhang steel nga support ang moment, no, ang magnitude, no. So ang sa ato kato ang solution, sa akong solution, this is the very, ano siya class, on point, no, kay wala man tayo round up kay disipan places lang man. Pag imo na siyang i-add, pila man ni class, kindly add 5,422 plus 993 plus 4,577.006. Pila man siyang result.
$9,999.93 sir.
Okay, so 9, ano to? 999.993?
939 sir.
939?
Yes sir.
So anyway,
Ay, isa ra pa
natay
kon, sir.
discrepancy.
Isa ra
So
pa kon, guys.
if ilas na to na siya by 10,000, dare. So 93. So it's only a matter of 0.07, tama ba? Para mag 10,000. So if ato ni siyang i-kuan class, ang sabot mo kay nag-play safe siya para ma 10,000 rate. So ang ihabit tong torsional diagram. Kay if ato na siyang i-graph, ato i-graph ha, asa tong figure. Di ba I have mentioned earlier na dapat mag-zero ang imuhang torsional diagram. So, if atong i-draw iyahang torsional diagram, ang sabuk perfect zero gina ang iyahang graph, no? Kay iya magipang round up, round off. So at aluminum, di ba positive sign convention ta ani? Kung right hand rule atong convention is right hand rule man, no? So positive sign convention, so value of your PAL, di ba si siya, si 4,577. Sige, so meaning musakan na siya by 4,577.006. Then again, walay portion or moment nga nag-act sa ato ang member in between junction. So, constant lang na siya all throughout. Meaning, this is also 4,577.006. Now, then, pag abot kang junction, no? Sige, i-name na to siya at junction C. So, at point C, you have a negative sign convention of torsion. Meaning, mo go down, tanong mo naog ta. So, 4,577.006 minus 10,000 kay this is in 10 kip inches man. So, and these are pound inch. So, ato siya i-convert into pound inch, no? So, 10,000 na siya. So, 4,577.006, you'll have negative pila man. Sige, class. Pila man ang 4,577.006 minus 10,000.
So to, sir?
Pila to? Negative. So, of course, that should be negative kay mas tako man ang magnitude sa tong 10,000, no? Negative sign. So, negative 5,422.994. Sige, negative 5,422.994. Okay? So, meaning, again, for the point C2 still support, ano? So, constant lang. So, meaning, at that point or at support sa steel, you also have negative 5,422.994, no? And ang PST, how much? So, 5,422.993. So, okay. So, 0.01 lang ato ang discrepancy. So, mag-close lang hapon ang siya class, no? Ang importante class is that pag mag-drawing ka of force diagram or torsional diagram or shear and moment diagram class, no? Perfect if equal to 0 gyud siya, no, nga 0.000 or 0 gyud. But due to decimal places bitaw class, no, nga discrepancy in which ikapila na ta nag-round, no, from here nag-round up ta, from here nag-round up ta, dari nag-round up ta, asa pa man diri nga part round up, di ba? Daghang kita gitang round up. That's why muna siya ang na accommodate no, na accumulate nga descriptive. But anyway, this is not sayop, no? This is also acceptable or this is actually correct. It's just that unsa man ni murag siya na itsura og ilong sa baboy. It's just that um discrepant dapat nimo class dili na siya mo greater than 1, ha? Ayaw lang gina siya pagura og discrepancy nga lugar. Example, nabot ta diri og di ba 522 522. Then ang atong TST kay ano lang siya 5421 sirado. So almost 2 ang imong discrepancy. So sayop na siya class, ha. Ang acceptable lang class nga discrepancy or error class is nara sa mga 0.09, 0. Okay raya ko na siya, no? Actually, yan ka ng 0.9, ako nangali na siya. So, if nakakuha ka ng discrepancy nga 0.5, so, ambot, okay na siguro, okay na siya, acceptable na siya, no? Mga 0.8, kana class, dako na ni sila, no? So, all you have is recheck, i-retrace ang imuhang solution base na lang kay nadakuan og round up ba, no? Or na lang kay nasayop og input, okay? Basta ka ang acceptable class, it should be a very little lang yun nga discrepancy. Okay? So, it's a good thing na tackle na to ni siya karon, no, kay this will be used sa ato ang next topic yun class. We will indulge yun more on in this diagram. Okay. So, other questions or clarifications? Okay na ba? Nasabtan ba?
Yes, sir.
Well, yes, sir.
Okay. So, when you, Bear, wait lang. Okay. Anyway, ano lang yun na ang kanin mo sa bukay naka-fraction. So, wala siya yung decimal places, meaning accommodate ganito na decimal places. But if you will try to solve this, try daw siya solve if ano ba yun ang resolve? 5,420 and 4,580, no? So, I'm not sure if exact yun na. Yun na siya decimal place siguro. Iyara yun na gikuan. Okay, anyway, it's just the same magyapon, no? Decimal place nga, may lang kay ang discrepancy, ang difference. Okay, so if wala na questions or clarification, so I have already informed you your midterm examination schedule. So before lang mo i-dismiss, ato i-record ang iyong attendance. So say present if you're here sa meet. To L. Aberin Monique. Abrenica Hana.
Present, sir.
Asibar. Okay. Asibar Maria Christine.
Present, sir.
Baconga Lloyd.
Present, sir.
Bastatas Joby.